Welcome to the Shearwalls online tutorial for the US edition. In this video, we will go through the content of the hold down design and collector forces tables from the design results. This is the same existing model used in previous videos of this series, but for the purpose of this example, we have added an additional story to the structure. The loads have already been generated and we will now run the design. The project file for this two-story structure is available in the description below. The hold down design table, which is accessible from the Go To Table tab, summarizes the tensile hold down forces, capacity, the hold down models, and most importantly, the ratio of the combined force and the hold down capacity in the far right column. The layout and information provided in this table is similar in the case of wind or seismic design, assuming either a rigid or flexible diaphragm distribution for a total of 4 tables. Checking all 4 tables can be time consuming, so instead what you could do is go to the design summary page where information on whether the hold down has failed or not is displayed, as discussed in the previous video. Hold downs are grouped by level and shearline. The location shows the plan view X and Y coordinates of each hold down, followed by the critical load case from ASC 7, which is described in the legend below. The tensile ASD hold down force column is where the force at the tension end of each wall segment for each direction from the critical wind load case is reported. The shear overturning component is based on the horizontal shear force only, in this case due to wind forces distributed using the flexible diaphragm assumption. The vertical dead load resisting component and the wind uplift component are populated only if we enter those loads manually. The combination of the tensile forces due to the shear overturning force and the manually entered loads is shown in the 4th column. The type of hold down is listed for each end of each shear wall segment for all stories in the hold down column. Cap is the design capacity or tensile resistance of the hold down. And the last column, critical response, shows the ratio of the factored tensile force versus the hold down design capacity. Where the critical response exceeds 1.0, the hold down fails to resist the applied force. The collector force information is shown here. Notice that only forces are shown. Unlike hold down, Shearwalls does not design for collector forces. That being said, you could use Sizer to design collectors. As for the strap blocking force column, it corresponds to the force in the strap or blocking above and below openings for force transfer walls. Note that the collector forces are based on either the shear wall capacity or the applied load, for both hold downs and drag strut. You can toggle between the two options in the design settings. To further understand drag struts, let's take a look at this image and force diagram. Drag struts drag or transfer the forces from the diaphragm above non-shear walls, such as window openings, to shear walls next to the non-shear walls, and that drag struts are usually double top plates that act in compression and tension, with nails transferring the forces across joints from one plate to the other. In this case, drag struts are required on both sides of the center segment shown in white, which is a shear wall segment. Drag struts forces are determined based on the cumulative shear force from the diaphragm at the top of the wall, minus the cumulative shear forces in the supporting shear wall segments. Since wind and seismic forces cycle back and forth, the collector is stressed in both tension and compression alternately. You can see the maximum drag strut tension and compression are located in both ends of the resisting shear wall. These forces are reported in the elevation view as well as in the design results. Just like other tables, the shear lines are grouped by level and shear line. Within the shear line, the position indicates where the opening starts and ends, and is related to the next column, location, which shows the X and Y coordinates in plan view. The drag strut force column displays the axial force in the transfer elements at the locations I just mentioned. For seismic design, the shearline force is displayed, which is calculated based on the larger of that based on ASCE 7 clause 12.10.2 and that based on exception 1 of 12.10.2.1. For structures with seismic design category D through F, the drag strut force shall be increased by 25% as per ASCE 7 clause 12.3.3.4 if certain regularities exist. As for strap or blocking force, the values are only displayed for force transfer wall types, as mentioned earlier.